Assalamu alaikum dear students. Today we are going to solve lost examples of question in this exercise second of this unit. Now here question is find the value of x for which the function y equals to x into x minus 2 whole square is an increasing function. This means that we have to find the value of x such that this function is increasing. Now we have y equals to x into x minus 2 whole square, which implies that we can write this as by multiplying it is x square minus 2x whole square. Now it is derivative, that is dy by dx is 2 into x square minus 2x, because by differentiating firstly in this index or the power, then we have to differentiate the base, that is it is x square minus 2x and its differentiation is 2x minus 2. Now for stationary points, that is dy by dx is 0 implies that 2 into x minus 2 into 2x minus 2 is 0. Since 2 is not equals to 0, which implies that its roots are given by x equals to 0, x equals to 2 and x equals to 1. Now these 3 points divides the entire set of real numbers into 4 disjoint intervals, that is minus infinity 0, 0, 1, 1, 2 and 2 infinity. Now we will check the sign of this derivative, that is dy by dx in these 4 intervals. Now interval minus infinity 0 and 1, 2, clearly dy by dx is negative, because when we substitute dy by the negative values, that is the values which belongs to minus infinity 0 or 1, 2, the value of this derivative, that is dy by dx is negative, which implies that in these 2 intervals, when derivative is negative, implies that this function, given function, that is y equals to x into x minus 2 whole square, is decreasing in these 2 intervals. Similarly in interval 0, 1 and 2 infinity, that is when we put x equals to that value which belongs to interval 0 and 1 or 2 and infinity, the value of dy by dx is positive value, or the sign of the value of this dy by dx is positive, which implies that in these 2 intervals it is increasing function. This means that when x belongs to this minus infinity 0 or 1, 2, this function is increasing, this is decreasing, but we have to find the value of x. Hence the values of x belongs to 0, 1 or interval 2 infinity, for which the given function is increasing function. Now another problem is prove that y equals to 4 sin theta upon 2 plus cos theta minus theta is an increasing in interval 0, open interval 0 and pi by 2, this closed interval 0 and pi by 2. Now here in place of x we have theta, so we differentiate with respect to theta. When we differentiate, we simply get 8 cos theta plus 4 upon 2 plus cos theta whole square minus 1 by differentiating. Here first term we will use this quotient rule of differentiation. In second it is theta, and differentiation of x is with respect to x is 1, which implies that differentiation of theta with respect to theta is only 1. So for stationary points we will put dy by dx equals to 0. When we put dy by dx equals to 0 by simplification or by using the cross multiplication, we simply get cos square theta minus 4 cos theta equals to 0. Taking cos common, it implies that cos theta into cos theta minus 4. Since cos theta is not equals to 4, because value of cos theta lies between 1 and minus 1, which implies that cos theta equals to 0 or theta equals to pi by 2. Now dy by dx is given by this, so by simplification it is simply cos theta into 4 minus cos theta upon 2 plus cos theta ka whole square. Now if theta belongs to interval 0 and pi by 2, this cos theta is positive, because first quadrant. 4 minus cos theta is greater than 0, because value of cos is less or equals to 1, which implies that 2 plus cos theta ka whole square is positive. Hence this whole term, that is derivative, is positive, which implies that y is here strictly increasing in 0 and pi by 2, open interval 0 and pi by 2. But we have to show that this function, that is y equals to this function of theta, it is increasing, simply increasing in closed interval 0 and pi by 2. In this interval, it is strictly increasing by derivative test. But at the points at 0 and pi by 2, this function is continuous function. When it is continuous function, which implies that we can find, or we have the particular value of the function at the endpoints of this interval, that is at 0 and at pi by 2. Since in this interval it is strictly increasing, which implies that there is a possibility that at endpoints the value may coincide with the nearest points. When it coincides with the nearest points, which implies that there is a possibility that the value of the function at endpoints is equals to the value of the function within the interval. So this means that we cannot say this is strictly increasing, but we can simply say that it is increasing function. It is increasing. Hence, in this way, this function is increasing function in closed interval 0 and pi by 2, but it is strictly increasing in 0 and pi by 2, open interval 0 and pi by 2. Now we have to find the interval such that this function x square into e raised to power minus x is increasing function. Firstly, we will find its derivative. That is, derivative by product rule of differentiation is 2x minus x square into e raised to power minus x. Now for stationary points or critical points, derivative is 0, implies that this x into 2 minus x raised to power into e raised to power minus x is 0, or x equals to 0 and x equals to 2. So these points divide the set or into 3 disjoint intervals, that is minus infinity 0, 0, 2 and 2 infinity. Now in this minus infinity 0, f dash of x is less than 0, because x is here negative, which implies that x is negative. 2 minus x is also negative, which implies that whole value is negative, which implies that in this interval minus infinity 0, this f of x is strictly decreasing function. Similarly in 0 to f dash of x, by substituting the values, it is greater than 0 means positive, which implies that in 0 to this function f of x equals to x square e raised to power minus x is strictly increasing into infinity. Similarly in interval this 2 infinity, in interval 2 infinity, the f dash of x is negative when we substitute the values, because here 2 minus x, we have to put x greater than 2, which implies that 2 minus x is less than 0. Hence it is negative here, which implies that this function is decreasing in interval 2 and infinity, which implies that we have to find the strictly increasing interval. Hence this function is strictly increasing in interval 0 and 2. So this is the required interval in which this function is strictly increasing function. Now we have to find the least value of m. Least means the value, there does not exist any value which is less than the given, which satisfies the given function. That is, we have to find the least value such that f of x equals to x square plus ax plus 1 is strictly increasing in 1, 2. Now here given function is x square plus ax plus 1, its derivative is 2x plus a. Now f of x is x square plus ax plus 1. Now it is given that this function is strictly increasing in 1, 2, which implies that by derivative test, derivative is greater than 0 for all x belongs to open interval 1, 2, which implies that derivative is 2x plus a is greater than 0, or x equals to x is greater than minus a upon 2, or a is greater than minus 2x by cross multiplication. But this is true only when x is greater than 1 less than 2, because x belongs to open interval 1, 2. When we multiply this inequality by 2, we get 2x 2 less than 2x less than 4. Shifting or change this inequality by subtracting, by this multiplying minus 1, we get minus 4 less than minus 2x less than minus 2. Here this minus 2x, now a is greater than minus 2x from this equation, but this minus 2x is greater than minus 4, which implies that a is greater than 4. So this means that a is greater than minus 4, for all values which are greater than minus 4, this function is strictly increasing in 1 2 interval 1 2. But we have to find the least value, which implies that a equals to minus 4 is the least value for which this function is strictly increasing. Because if we put if we substitute the value of any value which is less than minus 4, say for example minus 5, minus 6, minus 8, these are the values which are less than 6, this function is not strictly increasing. So this means that there is a lower bound for this a. So this means that we have to put only a equals to minus 4, which is the least value. Hence this is the least value for which function is this strictly increasing in interval 0 and 1. Inshallah, in tomorrow's video lecture we will discuss another property of this derivative, that is how to find the tangents and normals to a curve at a particular point. So thank you.